Okay, welcome back. This is just going to be a little review of 11.7 because in today's lesson on normal distribution, we're going to be referring back to this standard deviation. So what is standard deviation? Well, we typically use the lowercase sigma to notate it, and it's the square root of the variance, and it describes the typical differences or deviation between a data's value and the mean of the data set. So we're going to be using this standard deviation within our discussion today. So that is something we should really be familiar with. Okay, let's slide on. Today we're going to look at the normal distribution. A normal distribution is modeled by a bell-shaped curve, called sometimes the normal curve, and it's symmetric about the mean, which means that we have exactly 50% of the data below the mean and 50% of the data above the mean. The area under the curve is 100% or 1. All right, in a normal distribution, within one standard deviation of the mean, we have 34% on each side. So 68% of the data, remember it's symmetric, so 34 on each side, would fall within one standard deviation of the mean. Now, within two standard deviations of the mean, I get 95% of my data. So where do those 13.5s come from? Well, if you think about it, we take 95, take away the 68 we already knew about, and we have 27% left. Split the difference because we have that symmetry, and half of the 27 is 13.5. And finally, we know that 99.7% of data falls within 3 standard deviations of the mean. So again, where do those 2.35s come in? What are they talking about? Well, again, if you think about it, we've already gotten 95%, so we can just subtract them away. And we can see that if I have the 99.7, take away 95%, which is covered by the 1 and 2 standard deviations, we're left with 4.7%. And then dividing that in half, we see that 2.35%. So 68, 95, 99.7, and that describes a normal distribution. It has the symmetric shape of the bell curve, excuse me, and you see your percentages given here. And what are we measuring each unit with? Well, we're divvying the bell curve up by the standard deviation for that data set. All right, let's move forward. Take notes, pause if you need to. All right, so now we're going to see how do we use the normal distribution. Remember, the total area is 1 or 100%. 68% lies within 1, 95 within 2, and 99.7% lies within 3 standard deviations of the mean. Now you do have that 0.15 on each end, so keep that in mind when we're answering some questions. That's that last 3% divvied up symmetrically. Now, not all distributions are normal. Sometimes we say that they're skewed, and the tail is the tell to tell which way they're skewed. So if it's positively skewed, it means that the tail is longer on the positive side. If it's normally distributed, then you have the middle curve, and if it's negatively skewed, your tail is going to be longer on the left. Problem 1 from your textbook asks us to analyze analyzing normally distributed data. Now, we're given a bar graph here, so the mistake of a lot of students would be to try to use the percentages that we were just given But in this case, with the actual bar graph, we really want to approximate the weight of 100 to 129 by just tallying the heights of the bar. I mean, yes, it sort of fits the curve, but we're not using those specific percentages because this area is not shaded in. It's not completely fitting under the curve. We're just estimating with the bar graph. So if you're given a bar graph in some of your homework problems, make sure you're using the side scale to try to calculate what do you think this is at. If this is counting by fives here, it looks like it's more than halfway between 20 and 25. So my guess would be maybe 23. What do you think this height is? Well, it doesn't look quite halfway between 40 and 50. So maybe 42. And what about this one? Well, it seems the same as this previous one. So again, it's a little more than half. So I'm guessing 23. I'm estimating. I shouldn't say guessing. So if I want to find approximately what percent of female bears weigh between 100 and 129 kilograms, those bars. And you can see it here, the 23, the 42, the 23, and I get the 88. So 88% comes from these three bars. So let me just grab my highlighter, make sure you understand where I got those numbers from. So we said that this first bar right here went up to estimate 23. This second bar, that middle bar, this middle bar right in here, went all the way up past 40, but not quite halfway to 45. So we called it 42. And then finally, you see that last bar. That last bar is the same as the yellow bar. Whoops, got a little skewed over there. And that total was 23. So adding up those three percentages, because we can see what it represents over here is the percent. So we can find that 88% would be our answer. All right, let's move on. Now, how do we sketch a normal curve? So problem 2 from your textbook asks us to sketch the normal curve for a population of male European eels. So the mean body length is given as 15.7 inches. Now they've given us another eel that is 1 standard deviation above. So if I want to find the standard deviation, how did I get that 2.8 right there? Well, I took 18.5 and subtracted from it 15.7. So now I understand that the standard deviation is 2.8 inches. And then to draw the curve, I'm just going to keep in mind that it's a bell curve. And I'm going to put the mean in the middle and add and subtract 2.8 to each of those intervals, because that's my standard. So that's what it would look like here. So you can see I have my mean in the middle. And then if I add 2.8, I get 18.5. If I add another 2.8, 21.3, another 2.8, and we can stop usually at 3 standard deviations because that's usually what we draw for a normal distribution. And on the other hand, we're going to go ahead and subtract them. So make sure you have everything in place there. And let's try it again with our got it problem. Sorry about the little note there, I left that on. But for a population of female eels, the mean body length is 21.1, and the standard deviation now is 4.7. Do you think you could sketch that? Pause here and see if you can do it on your own, if you have the idea of what this would look like. All right, so if you tried it on your own, great job. let's hope that it works the same as mine. Draw the curve first if you want to, but I just divvied up the area. So 21.1 was my given mean. My standard deviation is 4.7, so each space is a 4.7 space. And I'm going to go ahead and just draw my curve and add and subtract the 21.1 minus 4.7 minus another 4.7 minus another 4.7 to get those values 16.4, 7, 11.7, and 7. And on the other side, on the positive side, I'm going to keep adding the 4.7. And if I asked what percentage of female eels have a length between 16.4 and 25.8 inches, would you know what to say? Well, hopefully you realize that that would be 68%, because that's within one standard deviation of the mean. And that's the rule for the normal distribution. All right, let's take a look at problem 3 in your textbook, and we're going to analyze a normal distribution. So the heights of adult males are approximately normally distributed with a mean of 69.5 inches and a standard deviation of 2.5 inches. What percent of adult American males are between 67 inches and 74.5 inches tall? So we're going to draw the normal curve. We're going to label the mean in the middle. And we're going to start with that 69.5 and then keep adding 2.5 to get to the right. We need to go to the left a little bit, at least one standard deviation to the left. So subtract that, or do we? Actually, I don't think we do need to go to the left. Oh yeah, one standard deviation to the left. So 69.5 minus 2.5 gives us that 67. Label the percent. All right, so we're looking from, we need it to go to the left just once. I mean, I guess you don't need to draw this if you get that. You could just stop there at 1. And 72, 74.5. So we went 2 standard deviations this way, and then we're just going to add up the 3 areas under the curve. So we have 68 plus 13.5, and that gives me a total of 81.5%, or approximately 82% of adult American males are between those heights. All right, try this one. The scores on an Algebra 2 final exam, or final, are approximately normally distributed with a mean of 150 and a standard deviation of 15. What percent of the students who took the test scored above 180? All right, so take a minute, see if you've got it, and then come back. So pause the video here and give it a try. Okay, so I hope you've got it. The first thing we're going to do is label the mean and the standard deviations. And what I've done is I've just added and subtracted 15s because 15 was given as my standard deviation. Next, I'm going to go ahead and label the percentages within the section of the normal curve and shade the corresponding areas. So I've got all my percentages labeled, and I can see my shaded areas right here. So if I wanted to answer the question, I would say 2.35% plus 0.15%, so 2.5%. 2.5%. All right, using the standard normal distribution. So now we're going to put the word standard in there. That's the difference here, and this is for population. So when we have a large amount of data, a large number of data, we can use the standard normal distribution, which is basically centered at the mean of 0. So if I say it's 2 standard deviations above the mean, I'm at 2 because I'm moving from 0. So it can fit any set of data if you think of your mean as being the 0. Now the formula to get your z-score and is the data item you're interested in, which is the x, minus the mean, which is the x bar. But now that we're talking about population, we often use the Greek letter mu. So this is the Greek letter mu right here. And that is really another way to say the mean. It's just that usually we just use mean with a smaller set of data, a sample, and then we use mu when it's a population. So you don't have to worry about that right now for Algebra 2, but as you move forward in statistics, you'll have more experience with that. The z-value for a particular x value is called the z-score. For the x value, and it's the number of standard deviations that the x value lies above or below the mean. So if I get a z-score of 2, I know that my data point lies 2 standard deviations above the mean. If I get a z-score of -3, then I know that my data point is negative or 3 standard deviations below the mean. And go back to my table. And if I wanted to read that table again, I would go to -1.5 right here and 0.00, and I would see that it's about 6.68% or about 7%. So I would use that answer right here. Okay. About 7% of newborns are less than or equal to 2,500 grams. Pretty nifty, right? And again, you can do that with a calculator. Let me see if I can slide forward from here. Let's see. Sorry. All right, so we've got that first one. On the next one, I won't go back, but you know that you can. What is the z-score? They just ask again for the z-score of a newborn weighing 4,500 grams. So again, we would use the little formula, noting that the mu represents the 3250. That was our mean, and that was given to us here. So maybe I should have put the mu right there. I don't even know if that looks like a mu now, but that's what it would be, which would be the 3,250 grams. And then number 3 asks for what is the probability. Okay, so now we've got probability. Now we actually do need the area under the curve. That a newborn weighs between 2,270 grams and 4,230 grams. So we're going to use the z-score of the weights and the normal curve. So what that means is that we're going to have to find the z-score for each. So let's find our first z-score with the 2,270 and our second z-score. And that looks pretty nice. So we're within 2 standard deviations of the mean. All right, now I'm going to go ahead and move on here. You can see I have my z-scores at the top that we just talked about on the previous slide. And remember, we're drawing the normal distribution, but it's the standard normal. So we don't need to put the numbers there. We're just counting 0 as the middle, the mean. And the 1.96, negative 1.96 would be somewhere over here, and the positive 1.96 would be somewhere over here. Now I went ahead and went to the Math is Fun standard normal distribution table. The link is at the top here if you want to give it a try. And I used the slider to calculate that percentage instead of using the table. Now if I were using the table, it wouldn't just tell me 47.5. It would actually tell me 97.5, because it's going to give me everything to the left of that 1.96 if I were reading the table. So this little handy calculator is kind of nice on this website if you want to give it a try. Now I also went to the other side to get the other piece, and now I have the betweenness on the curve. So if I want to find that whole area, I'm just going to add the 2 shaded regions. So I can see that 95% of newborns weigh between 2,270 grams and 4,230 grams. Now you can also do this on the calculator, and I'm sure you'll do this quite often if you end up taking probability and statistics next year, but I just wanted to mention it here if you want to go ahead and get a use for that calculator. So if you take out your calculator on the TI, and then from the home screen, you just need to be on the home screen, hit second vars. Now the vars key is in the second column from the right at the tippy top, right under sort of your arrow pad. And what sits above the vars, that second key, is bringing us to distributions. So we're getting to the distributions. And I'm going to not choose number 1 here, but it's number 2 that I want. So click number 2, or type in the number 2. Put your lower at negative 1.96, and put your upper at positive 1.96, and then just enter. I think mine says paste, my version, which means it's going to paste it into a parenthesis, and then you're going to have to enter and calculate. And I see that I get 0.95 or 95%. And that's the same thing you're going to get when you add those two together. So 95% is the correct answer here. Okay, let's move on. We have our follow-up questions, our exit ticket quiz. Think of it that way, you're leaving class. So we have 3 questions to go through, and then you'll answer those within your quiz. So the first one says the mean number of pairs of shoes sold by a daily by a shoe store is 36. So on average, they sell 36 pairs of shoes a day with a standard deviation of 3. On what percent of days would you expect the store to sell between 33 and 42 pairs of shoes? All right, so what we want to do here is think about that normal distribution. We would put our mean here in the middle at our 36. And then we want to find where that where the question lies. In other words, 33, where would that be? Well, if my standard deviation is 3, 36 minus 3 would bring me over here to 33. Now add the 3. Okay, so that would bring me to 39. Is that enough? Because if that's what I'm looking at, I know the answer is going to be 68%. But that's not quite enough. I want to go to 42. So 39 plus 3 more would bring me to the 42. Okay, so now I can do it. And then just add the 3 areas. So 34 plus 34 is 68, and then 68 plus 13.5 will give you your total, and hopefully you can get that correctly. So of course I forgot to say pause and try these first and then watch me do them. But of course you can pause if you need to, or if you would like the challenge. All right, number 2. What is the standard deviation for the normal distribution shown at the right? So what's the standard? Oh, that's what I'm counting by. The standard deviation is how much I'm counting. What's my unit of measure? What's my increment, if you will? So you can take any value and subtract from it its previous value, and hopefully you can easily see that that would be 6D. All right, let's go to number 3. A normal distribution has a mean of 700 and a standard deviation of 35. What's the probability that a value selected at random is at most 630? What does that mean, at most? Well, it means we want to get 630 or less. At most, doesn't say at least, it says at most 630. So I need the left of 630. So let's take a look at that normal again. And let me go back up here. I'm just going to use that same normal that we used for problem 1 and now rework it for problem 3. So let's see if we can do that. So I have my mean at 700. Whoops, 700 is going to be right in here. and my standard deviation is 35. I'm interested in 630, so I really don't need to put anything to the right. But if I go to the left, because I need to get smaller, subtract 35, I get 665 here. Don't need that. Subtract 35 again, and I get 635. 630, sorry. 665 minus the 35 gives me 630. And that would give me right here. So I need to figure out where that's going to lie on my standard normal distribution. All right, now I know that I want to shade everything left of it. So what is that area under the curve? A lot of students will make a mistake and say 0.0235. Almost. Don't forget that there's 0.15% way out on the tail here. Remember, within 3 is only 97% of the data, or 99.7% of the data. So we still have that 0.3% that needs to be divvied up on both sides, 0.15. So I'm going to add 2.35 plus 0.15 to get my percentage, and then change it back to a decimal. And hopefully you see that it would be 0.025. All right, so have fun with your Math Excel assignment. Enjoy that and review this video. I'll post it in OneNote also for you if you want to go back and review it again.